Compacting is an art. It has its rules. Years of experience have made Ham the undisputed specialist in this art. This experience enabled them to develop an innovative technology, compacting by oscillation. Compacting is an art, and every day Ham writes the rules that define the state of the art. Dynamic compacting systems enhance the compacting performance of a roller. But what compacting systems are available today? Let's start by looking at conventional vibration. Conventional vibration is produced by a means of rotating eccentric mass in the center of the drum. This rotation generates rocking movements in the drum, in other words, vibration, thereby considerably enhancing the compacting effect. The vibratory movement is circular, so we speak of circular vibrators as opposed to directional vibrators, which only vibrate in a single direction. However, in this process, the drum only has full contact with material to be compacted during half the operating time. During the other half, the drum does not apply any force to the material. In principle, therefore, a sustained cycle of compression and decompression is generated. Ham oscillation technology is also based on rotating eccentric masses, but with a different arrangement. Rotation about both axes generates oscillating movements in the roller drum. In this process, a moment of force is generated about the drum axis and then changes its direction of action during rotation so that the drum is made to oscillate. The force flow goes first in one direction, then in the other. As a result, with this to and fro movement, oscillation with a frequency of, for example, 40 Hz gives a compacting performance equivalent to 80 Hz with ordinary vibration. During this entire process, the drum is in constant contact with material, weighing down on it with its full static weight. The result is rapid and non-aggressive compacting. In other words, in the oscillation system, the vertically acting static weight and the generated horizontal shearing forces ensure that the material is very rapidly compacted. This system is used in particular in tandem rollers. In the VO drum, available for compactors, both systems are combined in a single drum. So the driver can select between oscillation and vibration. The compacting forces are produced here by the rotating eccentric masses. In order to produce the oscillating action of the drum, the eccentric masses rotate in the same direction and are offset 180 degrees from one another, as already seen. In order to switch the drum over to vibration mode, the rotating eccentric masses are equalized. That means they now rotate in phase with one another, thereby generating the vibratory movement. The VIO drum for compactors is used for a wide variety of earth-moving applications. In oscillation, the vibration stresses are much lower than with vibratory compacting. Oscillation generates only about 5 to 15% of the stresses generated by vibration. The power of the machine is not wasted producing unwanted vibrations in the environment, but is channeled accurately to the target material to be compacted. This reduction in vibration ensures a longer operating life for the machine, combined with optimal driver comfort. In the city, oscillation helps to preserve, for example, buildings and underground supply lines and drains in the area around the construction site. The stresses on historical city centers and residential buildings are considerably reduced. Here we can see, for example, an oscillation roller being used in an old historic city in Germany for the renovation of an old road. This renovation allowed new supply lines to be laid. The base course was compacted with a compactor equipped with VO drum, whilst the asphalt was compacted with one oscillation tandem roller. Oscillation rollers are especially required for bridges. They provide high compacting power without generating harmful shock waves. On these structures in particular, the asphalt cools down faster in the sea breezes. That is no problem for oscillation. Striking proof of this fact can be seen in these pictures of a ham oscillation tandem roller on a big bridge in Norway under the midnight sun of the high north. The high capacity of oscillation is demonstrated in particular on large sites, such as this motorway construction site. A rapid increase in compaction, 98% compaction was attained in only 3 passes, is coupled here with extremely homogeneous compaction and good surface roughness. Subbase remains undamaged. Outstanding daily work rates were achieved on this motorway with 3 tandem rollers. All these examples demonstrate clear advantages for oscillation. But why is this so? Allow me to examine the individual advantages in detail. Compacting operations are only possible within a particular temperature range, which varies according to the type of asphalt used. After a given limit, cracks or other damage occur instead of the desired compaction. At a given temperature, vibration has to be stopped. With oscillation, this temperature range is expanded by almost 20%. In other words, the oscillation roller can continue to work where the vibratory roller has to stop. The result is greater flexibility. What is true for the temperature is also true for the degree of compaction, which can also be increased by oscillation. Look at this diagram. With vibration, compaction increases, but after a given point, there is a risk of loosening or even grain crushing. Things are quite different for oscillation. Here, you can see that the strength of the material increases with each pass, without any unwanted side effects. The result is higher quality. At the join between 2 strips of road, such as here in the repair of lane grooves in one driving lane, oscillation prevents any damage to the other lane that has already been completed. In other words, already compacted and cooled. Even transverse passes are possible without any problem. There is no risk to the wearing course at any time. The high capacity in terms of rapid and high quality compacting is one of the key reasons why many construction companies have opted for oscillation technology. The aim of compacting is to produce as homogeneous as possible a mixture between liquid bitumen and the solid particles. However, the various compacting systems often result in too much bitumen reaching the surface. By contrast, the squeezing motion of oscillation ensures a highly homogeneous bitumen particle mix and good surface roughness for correspondingly greater traffic safety. The oscillation system developed by Ham is not based on complex mechanical control systems, but simply makes intelligent use of physical laws. As already mentioned, Ham oscillation is based on rotating eccentric masses that generate the oscillating movement of the drum. One major advantage of this system is its ability to adapt automatically to the subgrade to be compacted. But let's look at this process in an animation. Here, in the center, you can see the oscillation drum compacting a loose subbase. Here, the machine must work at maximum amplitude in order to compact the material rapidly. The system therefore operates in this example with a maximum tangential amplitude of 1.4 millimeters. Please look at the graph in the top right, showing the amplitude values from 0.9 to 1.4 millimeters. If the material consistency of the subbase now changes from soft to hard, the amplitude value is adjusted automatically. In other words, the amplitude is continuously reduced as a function of increasing soil stability. As the amplitude decreases, the amount of power transferred to the ground increases, as is illustrated by the thickening arrow at the bottom left. The fields underneath the arrow show the stiffness of the material. In the case of fully compacted, in other words hard material, as shown in this example, compacting proceeds with only a minimal tangential amplitude of 0.9 millimeters. This guarantees optimal compacting quality. The sustained static load and the changing dynamic shear forces in the material result in faster, better, and less aggressive compaction. Over many years of development, the drum design and eccentric masses have been perfectly matched one to another. This innovative system enables ham oscillation rollers to adjust almost instantly, within 10 milliseconds, to changing ground conditions. This corresponds to a traveled roller distance of only about 1 centimeter. By contrast, mechanical control systems respond much more slowly. Approximately 500 milliseconds elapse before a mechanical adjustment takes place, by which time the roller has already traveled between 50 centimeters and 1 meter. And in some places, this can already be much too late. Now, let's look at what happens in the soil or asphalt. The static load of the roller presses down constantly on the material, whilst the dynamic movement alternates its two directions. If the particles are arranged as illustrated in this picture, the static weight, vibration, or an automatically controlled directional vibrator alone cannot achieve anything. Here, oscillation operates from both sides and compacts the material. By contrast, if the particles are arranged as shown here, they are not shifted by lateral forces, but by the sustained downward static load. In other words, regardless which way the particles are aligned, they are always moved to the optimal position and thereby compacted. The result is better and faster compacting. You will without doubt be familiar with this process in your kitchen when pouring coffee or sugar into a tin. Tapping the tin on both sides compacts the material more rapidly. The basic operating principle of oscillation is the same. So, the oscillation system developed by Ham has a whole range of important advantages. No ground shaking around the machine, so that work in built-up areas, on bridges, in multi-story car parks or other sensitive areas is now possible. Extended temperature range for greater flexibility. Better compacting result due to rapid and continuous increase in compacting. Immediate adjustment to change structural condition of the subgrade. Self-adjusting amplitude without complex control mechanisms. No grain crushing due to non-aggressive compacting. Good initial adhesion of the asphalt surface due to homogeneous compacting. In short, faster compacting with a better result. Innovation is based on experience. This is demonstrated by the oscillation system developed by Ham. Once again, it opens up an entirely new dimension. You too can reap the benefits. Compacting is an art, and Ham shapes the future for you. We are in Tromsø, in Norway, in the country of the midnight sun. Here, in the north of the Arctic polar circle, the bridges and roads must be able to resist extreme stresses. The severity of the winter, with temperatures regularly dropping to -30 centigrades, causes accelerated wear of the road surfaces, in particular on bridges. A ham road roller was chosen to spearhead a renovation project concerning 2 bridges damaged by frost. This double contract for a global